Hey sixth graders, we're going to go ahead and start looking at some more complicated one-step equations. And we're going to sprinkle in integers because in higher level math we will have coefficients. Remember, those are the numbers that are multiplied by variables, and constants, which are the numbers that you're adding and subtracting that don't have variables. And these are going to be both positive and negative because unfortunately, in life, we don't always just have positive things. We also have negative things. And the beauty of algebra is that everything boils down to inverse operations. You are undoing a bunch of stuff to get the variable all by itself. So as long as you know your inverse operations, you're golden. That's the golden key to algebra. And when you have those integers floating around, you just got to keep your integer rules in mind. That's why we worked so hard last month on mastering those integers. So let's go ahead and take a look at a couple of different scenarios dealing with integers and our algebraic equations. So one case is we could have a variable and we could be adding a negative number. So that makes it a little bit more complex than just adding a positive 5. So again, keep in mind, we want to get the variable all by itself. That's our goal. In order to get the variable all by itself, I have to get rid of adding a negative 5. Well, how do you get rid of adding a negative 5? Well, we're going to use the inverse operation and we will subtract a negative 5. Now, subtracting a negative 5 is indeed the same thing as adding a positive. So that is the same thing as adding a positive 5 when we use our KCC skills. So let's go ahead and take a look at a couple of examples. So let's solve this problem, in fact. So let's set up our algebra T so that we can show our work and keep everything on the proper sides. So in order to get rid of adding a negative 5, again, I'm going to go ahead and subtract my negative 5. I'm going to write it out this way first so I can really emphasize what we're doing. Now remember, subtracting a negative is the same thing as adding a positive. So I'm going to go ahead and KCC that right now. So now this becomes negative 5 plus positive 5, which that cancels out. A negative and a positive, opposites, negative 5 and positive 5, boom, those cancel out. You're left with x equals 7. And we can check our work by plugging that back into the original. So is it true that 7 plus negative 5, is it true that that gives us 2? Yes, that's a positive 2 equals 2. We're happy. Very nice. Let's take a look at another example. If we have b plus negative 4 equals 10, I'm going to subtract a negative 4 to undo that because the opposite of adding is subtracting. So I set up my algebra T. I'm going to go ahead and KCC that, because subtracting a negative is the same as adding a positive. My negative 4 and positive 4, boom, they cancel out. Negative 4 plus 4 is 0. So you have b equals 14. Let's check our work. Is it true that 14 plus negative 4 does indeed give us 10? 10 equals 10. Beautiful. And the last one here, let's go ahead. We're going to subtract negative 3 from both sides. Oops, subtracting a negative 3. And I'm going to go ahead and KCC that. So that's plus a positive. That's plus a positive. Now I have negative 3 plus 3. That cancels out. I have m equals positive 1. Let's plug it back in. Is it true that 1 plus negative 3 gives us negative 2? Is that true? Negative 2 equals negative 2. Fantastic. Let's take a look at another scenario. What happens if we are subtracting a negative from a variable? Well, remember, subtracting a negative is the same thing, is equal to adding a positive. So the first thing we're going to do is we're going to KCC it right off the bat. So we're going to rewrite it as an addition problem using KCC because, in my opinion, addition problems are easier. Then we'll solve by using inverse operations. Because again, inverse operations, that's the heart of algebra. So we can set up our algebra T. I notice that I have x minus a negative 2. That is the same thing. I'm going to KCC that. That's the same thing as x plus positive 2 equals 5. And look how much easier that problem has now become. I want to get rid of the plus 2 because I want to get the variable all by itself. The way to get rid of adding 2 is subtracting 2. A positive 2 and a negative 2, boom, they cancel out. I'm left with x equals 3. Let's go ahead and look at this guy. I'm going to go ahead and KCC that right off the bat. That's the same thing as b plus 3 equals negative 2. I'm going to subtract 3 from both sides. Now this is where you got to be careful because you have an integer and subtraction, so you need to KCC this. That's going to be negative 2 minus 3. So when I KCC that, that's negative 2 plus negative 3, which gives you negative 5. And the last one here, let's go ahead and KCC this right off the bat. That's the same thing as m plus 10 equals 20. This has now become a much easier problem. M equals 10. Now let's look at what I think is the most difficult of the 3 scenarios when we're dealing with negatives. So sometimes we are taking the variable away from another number, which means that that variable is negative. The way we don't want it to be negative. So the way that we can make it positive is by adding that variable to the other side of the equation. Because if you remember, you can do anything you want to an equation as long as you do it to both sides. So to this equation, if I wanted to, I could add 100 to both sides. Does that help me in this case? No, but guess what? As long as I do it to both sides, I still will have an equation where my answer will still end up being the same. When my answer will be the same when I solve that equation. So you can do anything. You can add 100 to both sides. You could divide by 1,000,000 on both sides. As long as you do it to both sides, you can add your variable to both sides. So watch what's going to happen here. So right now, this is actually a negative x. I don't want my final answer to tell me negative x equals blah, blah, blah. I want it to be a positive x. So what I'm going to do is I'm going to add x to both sides because I can. So I'm thinking strategically here. I don't think you should have known this on your own, but that's why I'm showing it to you. Because what is a negative x plus a positive x? Well, those are opposites, and when you combine them, that's a 0 pair. They cancel out. A negative x plus a positive x is 0. So now we're left with, 25, sorry, that's a 5. 25 equals 10 plus x. Now these are unlike terms, so we cannot combine them. So we just write them like that. Now this is a much easier problem because now I have a positive x. I'm going to subtract 10 from both sides, and I get 15 is equal to x. Again, I can plug this back in to check my answer. Is it true that 25 minus 15 gives you 10? It sure is. Let's look at a more complicated problem with a negative as well as a negative constant as well as a negative variable. So again, this is a negative p because you have a minus sign out in front. The way to get rid of a minus p or a negative p is to add p to both sides, because a negative p and a positive p cancel out. So I'm left with negative 20 equals 5 plus p. Now I want to get p all by itself. This is a positive 5 or a plus 5, so in order to get rid of it, I need to subtract 5. Now this is where you got to be careful. You got a negative and subtraction, so you need to KCC this. So when I KCC that, that is the same thing as plus a negative, which is negative 25 as your final answer. And we can check our work by plugging it back in. Is it true that negative 20 minus negative 25 gives us 5? Well, if we KCC that, we would get negative 20 plus 25, which is positive 5. So we are correct. I just don't have space to check it. And let's do one more together. This is a negative q. I don't want my answer to say negative q equals blah, blah, blah. I want it to be a positive q. So the way I can turn it positive is by adding q to both sides. The q's cancel out on this side, so I'm left with 10. This is negative 4 plus q. I need to get rid of my negative 4, so I'm going to add 4 to both sides. Boop. And I get, q equals 14. Again, you can check by plugging it back in. So I want to know, is 10 minus 14 indeed negative 4? Yes, negative 4 equals negative 4. Fantastic. So go ahead and try these bottom ones on your own, and you can check my completed version on the website to see if you were correct.